Thank you. So, welcome everyone. Thank you for joining this talk. My name is Lajos Fülöp. I'm working as a Senior Data Delivery Manager at EPAM. And as you heard, I will talk about open source technologies and contributions in the fields of cloud and data. Yeah. So first I will give a really brief introduction, just a general overview, and then I will focus on two projects in which we have contributions from EPAM. One is the DQ from the AWS labs, and the other is the Apache Data Lab, which is actually initiated by EPAM as an open source accelerator. And at the end, I will give some further information to close my talk. So here we can see a really brief list, a short list of open source technologies in data and cloud. It would be not enough to talk only just one sentence about all of the technologies available in these 20 minutes. So I would just list maybe some of the most important ones. So Apache Kafka is an open source distributed email streaming platform. Spark, a multi-language engine for executing data engineering, data science, and other workflows on single or cluster nodes. Cassandra, it's a NoSQL distributed database. Parquet, a column-oriented data file format, optimized for efficient data storage and retrieval. Apache Druid, a real-time database to power modern analytics platforms. Y Superset for data exploration and visualization. I would also mention LocalStack, which is a really nice and really good tool to make your developments locally without touching AWS, and then it's much easier to deploy your solution or even just a prototype afterwards. And as I mentioned before, I will focus the talk on DQ and Data Lab. Actually, Data Lab started originally as D-Lab before. DQ is about data quality, monitoring data quality, kind of, we could say, unit test for data built on Spark. And Data Lab is an analytic toolset for exploratory data analysis, kind of a sandbox, available on AWS, Azure, GCP, depending on the choice. So first, AWS Labs DQ, built on Apache Spark, unit test for data. You can see here a figure. So we have the incoming data, we have matrix computation within Apache Spark, and then the matrix, and we can define the constraints or matrix. We may also ask from the engine for suggestions, like completeness, consistency, correlation, and so forth. And it's also possible to get data quality report at the end. And you can use DQ anywhere in your pipeline, extract before or after extract, before after transform, before after load, anywhere in the pipeline. And the key contributions from EPAM made by Robert Ambrusch, lead software and test automation engineer. You can see here a list of contributions. One was about the introduction of group metrics. The other was to handle unsupported column types properly in the data type analyzer, and the third one is about histogram matrix compatibility fix. So it was one of the contributions I wanted to highlight. And in the rest of my talk, I would really focus on the Data Lab, which was started as an accelerator at EPAM. So this is a toolset for analytics, a sandbox environment to run kind of exploratory analytics. Meanwhile, the infrastructure is prepared by data engineers. So the two things can happen in parallel. It's a self-service, kind of fail-safe exploratory environment with unified single sign-on. As I already mentioned before, on top of AWS, GCP, and/or Azure. You can see here some links where you can find some further information, and also the links to the open source accelerator at EPAM. And I would like to really highlight that the key contributors are from is the EPAM data and analytics practice. So a high-level overview about the data lab, the Apache Data Lab project. So we have these major building blocks: self-service, security service, provisioning service, billing, and Docker and the database. And our user is the data scientist. So the self-service, it's a RESTful user API with a web user interface for the data scientist, delegating all the requests coming from the user, especially to the provisioning service, and saving the different kind of states in the database. So these are really coupled, and the provisioning service, this is a RESTful service provisioning of the user infrastructure, and as I said, receiving the request from the self-service and forwarding to the infrastructure, and then sending back the response. So this is just really high level. We also have billing, providing the billing report within the database for each cloud provider. Security service, again, kind of a seamless and transparently wrapping potential providers or cloud providers behind. Again, a RESTful service. The Docker is about infrastructure provisioning. Everything goes through this. We will see in a much more detailed architecture later on. And the database storing user settings and all other information for provisioning. So this is the very first architecture diagram. We will have really similar ones for GCP and Azure. So sorry, let's show here. So we have the data scientist or data engineer on the left-hand side, who is accessing the environments through the self-service. Here we have the web UI with the MongoDB database, and we also have the identity with Keycloak. And we have an endpoint API still in a public subnet. This endpoint API is available also within GCP and also in Azure. And then we have the already mentioned Docker images to manage the resources, creating and so forth. The reverse proxy provides the connection to the private subnet. And here we have the data scientist notebooks, also the project data bucket, together with Git repository and the data sources. In the web UI, there is a bucket browser in which it's possible to upload, download, manage all the data and all the files or inputs, outputs. In the web UI, we also have Ungit to work with Git in a seamless, transparent way. And as you see, it's possible to define multiple project exploratory environments from A to Z. So this is not only one environment, you can define more as you wish, depending on your project. So this is kind of a full framework, a transparent framework for data scientists to play and run some exploratory data analysis in a sandbox environment. You can fail, then you can restart. Again, it's also possible to save your settings and what you are using in the notebook, libraries, whatever else, in images, kind of configurations that you can reuse later on when you are creating another environment, and so forth. What else to mention here? So actually, this is roughly the story behind. And we have a really similar architecture for GCP. I wouldn't repeat because this is kind of the same. Of course, the difference is the cloud provider specific technologies behind, but from data lab viewpoint, it's the same story. And also for Azure, we also have here the Git repository. We also have the notebooks and reverse proxy and so forth. Yeah. So some further information about these certain components. First of all, the self-service node. So here the user is able to create the environment and start the work. This is abbreviated as SSN. This is a kind of a main server. Here we have the UI for management and deployment of the components, and here we have the database for the configuration and user preferences, and also the Docker for provisioning and managing the provisioning of the other components behind. And also we have this endpoint for provisioning endpoint for the data lab resources. And actually the endpoint is a separately deployed component from the self-service node, and it's possible to deploy it on different cloud. In the background, the edge node, the reverse proxy for the communication, for connecting the public and the private subnets. And as I mentioned, Keycloak is used to manage the authentication for all cloud providers. Yeah. So let's go back to this architecture. So here we have the notebooks, and maybe the question comes that what kind of analytical tools libraries we can use in these notebooks. Here you can see the list: Jupyter, JupyterLab, RStudio, Zeppelin, TensorFlow, and Jupyter or RStudio, and deep learning and Jupyter. Actually, Apache Spark is also installed for each of the analytical tools, and there is also a possibility to deploy an own GitLab server from the self-service node with a dedicated script. After deploying the notebook, the user, the data scientist, is able to create compute from the following options: either a Spark standalone cluster or cloud managed cluster platform, EMR, or others. Okay, so it was kind of a summary of the architecture and how the system works. So I would have some additional screenshots about the self-service web UI itself. So the very first thing, to create a project, and it's kind of really easy. Uploading the public key to start the project creation, following with other steps. On the left, you can see some other functionality or menu items for process management, environment management, and some other configuration management. The next, one of the another important thing, to create a notebook server. First, you can select the template. There are different, as I mentioned, there are different templates and libraries pre-installed. You can select from those. If you already saved some pre-configured environment or configuration, then you can also select this as an image. You can choose from different kind of instance sizes, and you can put some custom text, and you can decide whether you need GPU or not, and what kind of type, if this is the case. So this is the key steps for creating a notebook server. And this is about managing project even with different endpoints. Starting, stopping the different endpoints, and here you can see the 3 different endpoints with 3 different cloud providers. Actually, there are much more additional UI pages within this self-service node. For example, browsing the buckets I mentioned before, working with the Git, and collaborating with the other data scientists from this viewpoint. Anyway, please feel free to check all these links about further information, not only about these two projects, or especially Data Lab, but also other open source contributions of EPAM. And what I would also like to highlight that we have a monthly data meetup series in this domain with similar discussions in similar cloud data topics, technologies. So thank you very much for listening. And if you would have any question, I would be really happy to ask.
Thank you, Lajos, for this nice presentation. And as I see, we don't have any remote questions. So any local question from the visitors? No? Okay, so thanks again. And
thank you.